Bismillahirrahmanirrahim. We are going to start the discussion about the procedures which are involved in research generally for the authentication purpose uh, of hypothesis testing uh, in R. So the focus will be in two-dimensional. In the first dimension, we have to identify the problems, and then we will solve the problem by using the techniques in R. So it means we are not going to just learn the R here in this course or in this workshop. We are going to introduce the practical hypothesis testing procedures in the life or in the real life. The data file which I have chosen, as I already shared to you, the name of the data file is ToyotaCorolla.csv. I think all of you have this file with you, and we will work together in R. Regarding the procedures, the very first step in any of the research is to identify the hypothesis, or you have to identify your research. What are your objectives? What you want to do? This is the very first step. After specifying the research objectives, the second most important step is the collection of data. So by this workshop, we already have the data set. So I will just introduce the few of the problems or the few of the hypotheses related to the data set we have in the ToyotaCorolla.csv. I don't want to keep the workshop much theoretical because all of you are expecting that it should be a practical workshop in which you can do the real thing by yourself by the help of code. I have already shared few of the things to you. One file is the Toyota Corolla file, and which is the CSV file, comma separated values. Another thing which I have shared to you is code, which I will run on my computer, and I will explain the few of the contents of the code. I kept the code as simple as possible so that you are not too much worried about the learning of the code. These are the very simple commands in R, which we will implement to specify the solution of the procedures or the hypothesis we are going to introduce here in the workshop. So let me introduce the file first, and then step by step we will move towards the other things. Now the file is ToyotaCorolla.csv. These are the variables. Can you see my screen clearly? Can you listen my voice clearly? Okay.
Yes,
This is the file, but this is not the complete file structure. This is a file structure in which I have reduced the few of the column which are not too important, or we assume that in this analysis, we are not using that variables. I will mention all of the variable in R, but over this slide, I put only the few of the variable which are relevant for the sum of the hypothesis, which I will introduce here and solve, right? The price, the first thing is very important. You have to understand the each and every tidbits of your data sets. So your data set is a Toyota Corolla CSV file in which we have several variables. These are approximately 11 or 9 variables. These are price of the car. These are the prices of the old cars which sold in any country in a year, right? to the price of the car, the age, how old the car is, how much the kilometers the car has driven, the fuel type. There are the three types: petrol, diesel, CNG, horsepower, metallic color, automatic car, or non-automatic car, or a manual car. How much CC is there, number of doors, the quarterly tax, and the weight. So these are the variable which I reduced. I can say that these are the reduced variable, right? We have to we have to specify the types of the variable which are very important, because in most of the analysis, the types, defining the types of the variable is one of the very important step, because research procedure is based on the type. Suppose price. Price is a scaled variable, means is a numeric variable. I'm using just S for scaled variable. And the age is also the scaled variable. Kilometers is a scaled variable. But fuel type is not a scaled variable. Scaled variable means the numeric variable or a quantitative variable. Fuel type is not a numeric variable. It's a categorical variable. In research, we call such variable as a categorical variable, cat. But generally, these variables are stored in the data file as strings. So our first step is to convert this character variable or the string variable into factor. So what are the factors? Factor is the data type in R which deals with the categories. So how much categories I have? Petrol, diesel, and CNG. These three are called levels. So how many levels we have in this data set? In this variable? In this variable, we have three levels. The level means how much distinct values we have in the data set. Only three distinct values: petrol, diesel, and CNG. It means all of the cars belongs to all of these three categories. Baki, horsepower is a numeric variable, metallic color. These types of variable are called dichotomous variables. Dichotomous variable means those variables which has only two values. Metallic color, yes, one value indicating that the car is of metallic color, and no, zero means it is not metallic color. Similarly, the automatic car, yes, and it's not an automatic car, as a manual car, zero. So these two variables are called dichotomous. Dichotomous, another name for the dichotomous is a binary variables. Binary variables, these are the binary variables which we introduce here. So in most of the analysis, wherever we need this scaled variable or a numeric variable, we should have to use scaled variable. So we cannot use the metallic color and the fuel type and the automatic car in those procedures which needs the scaled variable. Similarly, the CC is a scaled variable, number of doors, how many doors the cars have, the quarterly tax paid by the customers, how much the amount of the tax paid by the customer, the weight of the car, right? So some of the variables are numeric variable or scaled variable, but the three variables are here which are not purely the numeric variable: metallic color, automatic car, or the horsepower, right? In R, every data set is stored in a structure named as data frame. So what the data frame in R? Data frame is a collection of variable. Means all of the variables which I introduced in this file is stored in a data frame, right? So I can say the data frame is what? Data frame. Suppose I am mentioning the car DF. The car DF, this is the name which I am choosing. The name of the data frame, you have to choose the name of the data frame, car.df, car df, or any name you can choose with some restrictions. Restrictions are what? Spaces are not allowed. The car df, and you have to store all of the variable in this. So you have to read the file because the data frame, all of the variables are stored in a data file named as ToyotaCorolla.csv. So read.csv and the bracket mention the file name, means the data Toyota Corolla wali file name. So this is the very simple format of creating a data frame. So what CarDF is? CarDF is a collection which will contains all of that 11 variables which were mentioned over the previous slide. These are not only these are, because in actual file I told you there are the more variables as compared to these 11 variables. So all of the variables will be there in the car.df. Then we will do what? We will reduce the irrelevant columns so that we will have a data frame of only these variables, right? I will introduce in this workshop few of the procedures which are purely numerical procedures, which needs the numeric variables, like linear model, regression model. These are the model which needs only the numeric variables. But some of the procedure I will introduce here, which needs one scaled variable along with a one factor or a categorical variable. Like we can have the prices of the different cars, like whether the prices of the petrol car are higher or the prices of the diesel car are higher or the prices of the CNG cars are higher. So which of these three categories have a higher prices as compared to the other one? So these type of procedures will need one variable which is categorical and other variable which is a scaled variable named as price variable, right? So side by side, I will mention you the code so that you will work with me how to read the data file. The very first step is how to read the data file. Now I'm sharing my R code to you. You can see right now. So your first command you can see on the screen. So before going to read the file, I want to explain the GUI, graphical user interface of R, right? These are the four windows. Upper left window is called script. So this is the script or R script. We can call it as R script. I produced and provide you the script which I am using. The analysis of Toyota Corolla sales data.r. This script you already have. If you double click over the script, then the script will automatically be open into the R Studio. The screen that you are watching is the screen of R Studio. It's not R, it's R Studio. R Studio is what? R Studio is the upper layer over the R. R is basically this is R. R console is the R. So whenever someone is calling you, you are using R means basically you are using R console. But R console is one screen over the R Studio. So do not be confused what is R and what is R console. So R is the language in which all of the commands are executed by a compiler. So this can be done by R console. So very simple to work over with R console, but scripts means the commands that you need to run to achieve any objective. All of the commands will be summarized and collected and gathered in a batch file named as script. So this is our script, this is our console, and this is environment. Environment means whatever the data I have created. Suppose I have created a data frame, train data frame, train.df. So this is the data frame which I was explaining a few minutes before. So this data frame contains what? This data frame contains 600 observations and the 8 variables, right? So it is a data frame, and remaining, suppose valid DF is another data frame. It has 400 observations and 8 variables. So these are the data sets. These are the data sets loaded into R. So if I will run this command, then another data frame named as car df will be added here in this list. And you can scroll that data frame car.df, which will contains the all of the rows, which will have, I think it has about 1400 rows and maybe 39 or 29 variables in this data frame, actual data frame. The last window which we have here is the graph or the plots or the outputs window, in which all of the graphs will be mentioned here. There are the several purposes of the every
Can
screen.
I interrupt, sir? Akhtar sir, can
Ji,
I
please.
interrupt? These observations, what are these?
These observations I worked during my last sessions, right? So these are the files which I used earlier, which are mentioned here, right?
Okay, okay, all right.
When I run the command, then I will mention you the car.df will be added here, and another data frame will be added here, which will have 11, which will have about 29 variables and 1400 rows. So the rest of the windows which we have here is a history window. History mean whatever the commands I will run in the R console, the commands will be appended and added in the history, right? So history means what? History means the commands which are executed in R console will be added here. So there are the several tabs over the every window. You can see the purpose of the each and every tab. The last thing in the bottom is the files. Whatever the files I am using, all the files in my current folder are mentioned here. The graphs which I drawn earlier. I did not draw anything here right now, but previously what I did. So these are the graphs which I did previously, right? Packages are the external commands are stored in packages. How to load the package, how to do that, I will mention you here. So these are the very simple screens. You have to understand the each and every screen, whatever you have over in our studio. So this is all of the 4 screens are collectively making an IDE of R, right? Integrated development environment. All of these 4 windows are collectively called IDE. Now, I am just running the file here for you. So when you want to run the file, when you want to run the command, sorry, not run the file, all of the commands which I already shared to you are here. So this file is not new for you because previously I shared this file to you, right? So your first command is what? Your first command is read.csv and your name of the file is Toyota Corolla. So this is the name of the file. But because this data file is stored in a folder, so you have to mention the name of the folder, which is called path, in which the data file is stored. Otherwise, you will face an error that the file not found, right? So be remembered to change the path of your computer. The path, if you did not change the path, then you will face an error, right? I'm just executing the command. On the R console, this is R console. When I click the run button, the commands will be copied here in our console and executed because every command will be executed here. Just run. So the command has been run successfully because one arrow after that, another arrow indicate that there is no error. But if I change few of the things, suppose I change the folder name. This is. And now I am running the same command again. You can see the error. Why this error is occurring? The reason is the folder name in which the file is there. I did not mention correctly the name of the folder. So this error you will be facing in that case, right? Now the car DF is there. Just look here, car DF, this one. This is the car DF, which is created right now after my execution. The car.df, it contains 1436 rows, means it contains the data of 1436 observations and 39 variables are there. So now we want to check what are these variables, because I mentioned over the slide only the few of the variables like 11 or a 9 variable, whatever they are. So now I want to see the actual number, our actual size of that. The next command is structure command. You want to see the structure of this data frame. Now, the entire file throughout this script, I will represent by this name, car.df. So car.df is what? Car.df is my data frame, which contains all of this data, 1436 rows and 39 columns. You can assume that it is an Excel file in which we have 39 columns and 1436 rows. Every row contains data of one car. Now, car.df structure, how much observations we have in this structure. Now run this one. You can see the structure. This is the structure. I run the command structure car.df. It mentioned 1436 rows, 39 variable. First variable is ID, second is model, third one is price, fourth one is age, month, year, and kilometers, metallic. So some of the variables are those which I mentioned over my slide, but some are not mentioned. So these are the new variables here, cylinders, how many cylinders the car has, how many gears the car has. So 39 total variables these are. And every variable has type. What is the type of this variable? The variable type is integer. Integer is a type which is integer is a type which is for numeric variable. This is a character variable, means string variable. This is integer variable against price, integer variable, character variable. This is the variable. It is in characters, but we have to convert it into factor because it has only the few of the variables, a few of the values, only the 3 values as I mentioned earlier. So now I am going to move further, and if any one of you have a question, just raise the question before moving next. Okay. Can you run the code again from the very beginning and go through the columns, and I think that problem will be solved.
Okay, sir.
Okay. Now, I'm not running this command because I do not have any NA in my data frame. If there is a 0 in the data set, so 0 is not an NA. NA is a missing number. 0 is a value. Suppose someone got 0 marks in an exam, so it's not NA. So 0 is there, and we should have to analyze the 0 in the data set, right? Now coming to the next command, and that command is, again, I am checking the structure, 11 variables and 1436 observations. And now we have to see the data. So there are the two commands. One command is the head command, other is the tail command. Head command will mention you the first 6 rows of your data set. The price of the first car is 13500 and it is 23-year-old, and the kilometers it's run 46986. It's of type diesel. Horsepower is 90 cc. cc is the engine capacity, right? Now it has 3 doors and it has a weight is 1165, right? One student is asking, some of the information is very confidential, like your CNIC numbers. If someone has a data set in which the CNIC numbers are of all of the customers are there, we must have to remove the CNIC column because it keep very important confidential information. So those columns which are relevant, we have to keep them. Other columns we have to reduce, right? So I want to keep the analysis very simple. There is a chance the data file has more relevant variable, but at the moment, I am assuming that these 11 columns are very important. So it's depend on you, it's depend on your strategy, it's depend on your need, it's depend on your research questions, what columns are relevant and what are not. Some of the columns, the procedures will identify. I am assuming that these 11 columns are important. Later on, after implementing the procedure, few more column I will reduce because I will assume these columns are not relevant for a specific analysis, right? So how many columns are important and how many are not, it's a decision of analyst. The next step is I want to change the name of the few columns. Suppose age 84. What is age 4? It is 2004 and August 2004 because it is mentioned here these ages were computed at this date. So date, because date is a relevant variable and this variable is a relative variable, means if you calculate the age in 2014, then your age now, right now will be different that your age was at that time. It means so I'm changing the name of the column. The call names, CarDF, which column name I want to change? Column number 2. Column number 1 is price column, which is same. Column number 2, age column. I want to change the name of the column as in the age to keep the column name as simple. This is not necessary step, but to make the column names very easy, handy, and understandable. So this command you can run. So I'm just running I select all of these commands and run. Now I want to check whether the name of the column has been changed or not. Now you can see age. It is not age August 2004. It's now age only. F type, not fuel type, is a large name. I reduce the name column list. Matlick and auto. So these are the few columns which names I changed. So now quarterly tax, reduce the column name as quarterly tax. So this is the very simple handling of data. Right now, what we are doing, we are just pre-processing the data. We did not start any analysis right now, but we kept the analysis. We are basically prepare the data for the analysis. The next step is to convert 3 columns into factors. As I mentioned you, some of the columns are string, but some of the columns are factor. Can any one of you tell me what is the difference between a factor and a string? I want any participant to answer it.
सर फैक्टर में आपका कैटेगोरिकल होता है और स्ट्रिंग में सिंपल आपके स्ट्रिंग्स होंगे.
Right. Very good, Puratulan. In string, your name is a string, but your gender is a factor. Your address is a string, but your grade is a factor, right? Your CNIC number is a string because every person have a different CNIC number. It's not a category, but your subject is a factor because some of the students from computer science, some of the students are from physics, some of the students are from uh, business studies. So means these are the factors. So I converted all of these three variables into factor. After running these commands, I will mention the structure again. Now you can see that is a factor. Matlick is a factor with two levels. Levels means 0 and 1. One is indicating that car have a metallic color. 0 is indicating that the car is a non-metallic color. Now the another thing is fuel type. Fuel type is converted into three levels: 0, 1, 2. CNG, diesel, and petrol. 1, 2, 3. These are the three numbers which are created by the software by converting. Similarly, the automatic car has two levels: 0 and 1. 1 means the car is automatic. 0 means the car is manual. So after converting the variables into factors, we can analyze these three variables in a more better way as compared to them keeping as strings. Now we are creating some of the visualizations. Box plot. Command is very simple. Box plot. For which variable I want to make the box plot is a price variable. So how to write down the price variable? The syntax is name of the data frame, df, place a dollar sign in between the variable name and the data frame name, and price. So this is the format of using any column name in any command. Data frame name, dollar sign, price. If I want to mention the price of any specific car, I can keep another thing, and that thing is 5. So it will be the price of the 5th car only. If I remove the square bracket, the all prices of our car means all values in this price column. If I put the square bracket and mention a number in the square bracket, that square bracket will means the price of that specific car, right? So now the next is box plot, creating the box plot of price. So you can see the box plot is on the screen. This is the box plot, and your box plot is vertical. I want to convert the box plot horizontal. So just add one more parameter here in the command, that horizontal is equal to true. If you run this command again, your box plot will be on. Now you can see the box plot in detail in a clear visual version. These numbers are called outliers in data analysis. This is called third quartile. No, I'm sorry. This is not the third quartile. This is your third quartile. This is Q3. Third quartile, 75% observations are below that. This is your second quartile, also named as median, Q2. And this is your quartile 1, Q1. So these are the 3 points: quartile 1, quartile 2, quartile 3. And this is called, this length is called lower whisker, and this is called upper whisker, or the left whisker, right whisker. Okay, whiskers if the right whiskers is longer than the left whisker, we can see that the distribution is a right skew distribution. So if we want to check the normality, so it's not normal, it is slightly right skew. So what the box plot is mentioning, that the distribution of the graph is rightly skewed or symmetrical. Now coming to the next point, transformation. If it is right skewed, I can mention the same thing by histogram. So you can see the histogram. Mention that the distribution is right skewed. As I was telling you, this distribution is right skewed, and you can see clearly here the distribution is right skewed. Now, if you want to make the distribution normal, so a technique is referred to as transformation. What the transformation is? Transformation is a technique which make the data in normality. If your data is not normal, then transformation will make the data normal. Suppose you have a right skewed distribution and you want to convert the distribution into symmetry. So in between the two, we have transformation. Transformation is a very simple technique. You have just to take the log of the price and plot the logged values of the price. Or if it is not symmetrical after taking log, so you can try the another transformation, square root transformation, square root of price. I'm sorry, it's not log, it's square root of price is another transformation. So I will mention the transformation in our code by just running. You can understand what is the highlighted portion of the command. The highlighted portion of the command is log of what? Log of CARDF dollar price. Means we are taking the logarithm of all of the prices. And then after taking the logarithm, we are making the histogram. Histogram is this graph, right? Now I'm running the log version. Now you can see that the graph is more symmetrical as compared to the previous one. So after taking the log, the graphs become symmetrical. The technique is referred to as transformation. So what is the purpose of transformation? The purpose of transformation, if there is a skewness in your data, then you can take the transformation, make the data symmetrical. So it is symmetrical right now, while previously it was right skewed. Is it clear to all of you? What is the purpose of transformation? Now, if you want to take the logarithm, instead of logarithm, if you want to take the square root, as I mentioned you, the square root of prices, the SQRT function I used. What is SQRT function? Your SQRT function is taking the square root of the all prices and then making the histogram. After taking a square root, I'm just running the command again. You can see that after the square root, the symmetry will not change. It is still right skewed. It means out of the two transformations, one is the square root transformation, other is the log transformation. You can see the log transformation is better in this data set and in this column. There is a chance that in another column, if data is not symmetrical, then there is a square root transformation which will benefit us instead of log transformation, right? So it is not any static process. It's a dynamic process. Depending on the column, depending on the data, your transformation will be changed. Now coming to the descriptive measures. There are the procedures which I want to mention here before going to start actual analysis. Up to now, what I was doing, I was preparing the data for analysis. Now I assume the data is prepared up to a certain level. Now I want to apply some of the procedures. There are the three major types of procedures in data science, in machine learning. These procedures are mentioned here. Some procedures are called descriptive procedures, inferential procedures, predictive procedures. These are the very three important types of procedures. Descriptive procedures means describe the data. Very simple definition of the descriptive measure is what? Describe the data. Data means columns, values. We have to describe the each and every column. We have to describe the values. So finding what? Finding mean, finding median, finding variance, finding correlation, finding covariance, etc. Finding probabilities. All of these calculations steps are referred to as descriptive measures. In exploratory data analysis, EDA, there are the two steps in EDA. One is visualization, and I can also call it as EDA for preparation. Whatever we were doing, prepare the data. And the second step is descriptive, which we are describing right now. And the last thing is inferential. So I'm sorry, it's not inferential. It's analysis. It's analysis. Analysis means you have to find out the things. Descriptive measures and visualization, sorry. The three steps in EDA. What is the first step? Data preparation, finding the descriptives in your data, visualization, making graph. Ji Jamal, what your question is?
Sir, my question is if we find the probabilities, so won't it be considered in the predictive and
Yes,
predictive procedure?
yes, it is predictive. If we are predicting the probability of losing a customer, then the procedure is predictive, right? So by a model, we are predicting the probabilities. By simple formula, if you are computing the probability by simple formula, what the simple formula is? Probability of A is equal to how many elements related to A out of the n observations. So this is the simple finding the probabilities by the given data. If you are simple finding the probabilities by the given data, it is descriptive. But if you are predicting a probability by a model, what is the chance that a customer will churn in the next month, will not buy our product? So predicting the churn probability is a predictive procedure, not the descriptive procedure, right? Achha, in inferential procedure is what we are doing. I will give you the one example of inferential procedure, two examples of inferential procedures in which we have to compare the two means, we have to compare the multiple means by ANOVA. These are the inferential procedures. And I will give you in this workshop one complete example of predictive, which is linear, right? I kept the workshop as simple as possible. Any other question by Jamal? Do you have? Okay. Now coming to the R script again, finding the mean and variance. Finding the mean and variance, this is a descriptive procedure. So I'm just put any just kept the two simple commands, and that commands are what? That's command are finding the mean of the prices, finding the variance of the prices. Just run these two commands. So the mean is 10731. It's an average price of car. In analysis, we will mention is X bar, sample mean. It's a sample mean which is 10731. Whatever the unit is there, dollar or the pound, whatever the unit is there, you should have to keep the unit. It's a simple mean, not a population mean. If you are interested to find out the population mean, the procedure is called predicting the population. So we are predicting by the inference. We are predicting by the inferential procedures, right? So estimation procedure is called this. Estimated price of all such cars in US. Suppose the data belongs to the US. I have the data of only 1436 cars. The mean price of 1436 car is this. But I'm interested to predict the average price of all US cars of brand Toyota Corolla. Then this can be represented by mu. So by simple estimation technique, we call it as a point estimate. The sample mean is a point estimate of the population mean. So we can say that the average price of all Toyota Corolla cars in US is 10731. Estimated price. This is an estimated price, not the actual price of car. This is. Okay. Car DF, I did not created the car DF right now, DF1 right now. So I will create the car DF1 again after few of the procedures. One student is asking Sunil Kumar, still you do not have the car DF1, then why variance of car DF1? Car DF1 will be introduced later on. So there are the two data frame, one is the car DF and other is the car DF1. Just removing one. You are right, Mr. Sunil. Variance of car DF, not car DF1. Very good identification by Sunil. Now you can see that the actual price was 14,053 something, but now it's now 1315487. Very good, Sunil. The car DF1 will be introduced later on in this analysis. So I changed the DF1 from here. Now finding the summary statistics. Instead of finding the mean of prices, instead of finding the mean of HP, the mean of all other columns, just one command to find out the mean and the other measures, other descriptive measures of entire data frame. Still, I am just mentioning the summary of the prices. Sorry. In this summary command, what we are doing, we are computing the summary statistics of prices. Run it. In summary statistics, we have 6 observations. What that 6 observations is? Minimum value, the first quartile, the median, the mean, the third quartile, the max. These are the 6 observations which is provided by the summary command. If you want to find out the only first quartile, if you want to find out only the third quartile, so still you can do store the summary command in a variable. The same command I am executing, this is. But right now, I am storing the output in a variable called array. So what is S? S is a new column in which the summary statistics result is stored. I am executing and you can see that S is created. If you want to see the observation in S, just press S and enter. So all of that 6 values which were mentioned you in the previous command are stored in S, and you can access the element of S. How many elements S has? It has 6 elements. S1 contains the minimum, S2 contains the first quartile, and so on. If you want to see the second quartile, if you want to see the first quartile, just run S2. Only the first quartile is. If you want to see the third quartile, this third quartile will be stored in 1, 2, 3, 4, 5. So S5. So S in the square bracket 5. You can see the third quartile value is this. If you want to find out the maximum value, so you can have S6. S6 will contains the maximum value. Is a very dynamic nature of R that each and every output is stored in a variable, and you can access each and every tidbit of your object. In R, variable is called object. In high level languages, in object oriented languages, this is an object, which is basically a column, which is basically an array in which the 6 values are stored. Now coming to the next point, if you want to see the summary of all variables in by one command. Now it is summary cardf. So in summary cardf, the summary of all of the variables will be mentioned. Now you can see the output. This is your command summary, which was executed right now. Price column. Price column, minimum value, the maximum value, the first, all of the 6 values are there. Age column, all of the 6 values are there. Kilometer, fuel type. Very interesting thing, fuel type is not numeric. So for the fuel type, what do you have? For fuel type, you have frequency table. It's a frequency table. How many CNG cars you have in this data set, how many diesel cars you have, how many petrol cars you have. Similarly, these two variables are also the numeric variables, not numeric variable. These are factor variable. We convert them as factor variables. So how many automatic cars we have? Automatic cars are 1356. And how many, I'm sorry, it's vice versa of that. Manual cars are 1356 and automatic cars are 80 only. How many metallic color, how many cars have metallic color? 969 cars have metallic colors and 469 cars have a non-metallic color. Similarly, the summary statistics, the maximum number of doors is 5, right? The minimum number of doors has 2. And similarly, we have the mean number of doors and etc. So very simple and a very powerful command is the summary command, which will gives us a complete statistics of complete data frame. All of the variable in your data frame can be analyzed by simple. If you want to see the summary frequency table, so another command is a table command. You have to mention a factor variable in the bracket. F type, fuel type is a factor variable. The table command will work only with the factor variable. So if you want to make a frequency table of this variable, so you can see the same statistics will be generated here. CNG cars 17, diesel cars 155, and there are 1260 cars. You can generate the two-way table, which is referred to as contingency table. What is contingency table? Contingency table is a two-way table. Two-way table in which we have two-dimensional table, in which we have the two-dimension rows as well as column. It's a matrix structure. So matrix structure will be displayed by the table command. Next table command is what? I want to see the frequency table of fuel type. I'm sorry, fuel type and metallic color. So these are the two factor variable. These are the two categorical variable, and I want to make the frequency table collectively. So your table will be this. means how many cars have metallic color and how many car does not have metallic color. There are 13 cars which have metallic colors and their fuel type is CNG. There are 354 cars. There are 354 cars which has metallic color and they have a fuel type of petrol. So this is a complete statistics by you can increase the number of parameters in this table command. The next command is table command. Again, I will have three variables: fuel type, metallic color, and automatic car. All of the three factor variable I am using in one table command. So you can see what the output is. The two tables are generated and the last one is 0. The first one before the comma is fuel type. The second after the comma is metallic color. And the third is automatic car. So 0 means manual car. So this table belongs to the manual car and this table belongs to the automatic car. So it's a very dynamic command which help us to identify the frequency tables. Now the last command under the heading of descriptive is accessing any specific segment of your DF, your data frame. Your data frame has having 11 variables and your data frame having 1400 rows. If you want to access only the 5 rows, so in the data frame, in the square bracket, in place of rows, just mention the row numbers 1:5. So row number 1 up to 5. And which columns you want to access? Column number 3, column number 6, column number 8, 3 columns. So you can specify any of the sub matrix in a square bracket to watch the data. Now the data is mentioned in the output. Row number 1, 2, 3, 4, 5. Column number 3, 6, and 8. Column number 3 is a kilometer. Column number 6, metallic color. And the column number 8 is CC. And the data segment of 5 rows, first 5 rows. If you mention as 13 up to 55, then the data from row number 13 up to 55 and column number, these 3 columns will be mentioned. So you can see that the 3 columns and 13 up to 55 is there. So this is the end of the descriptive measures. Now from here up to onward, we will start inferential procedures. 2 inferential procedures will be introduced. One is called comparing two means, and another one is called ANOVA, comparing multiple means. And one predictive procedure will be introduced in this workshop, and that is called multiple regression. So before going to next, I will ask you if now we are going to start the second segment of procedures, and that procedures are referred as inferential procedures. So what are the inferential procedures? Inferential procedures is basically the hypothesis testing procedures. Example is there. Suppose in a company, males are claiming that the females are taking the high average salary as compared to males. Sorry, as compared to females. Males are claiming that the females are taking the higher salary as compared to females. So your hypothesis will be what? Your hypothesis H naught is average salary of male and female is same. This is your null hypothesis. And your H1 alternate hypothesis is mu M is less than mu F. This is your alternate hypothesis. Now we have to compare the two means. Average salary of male and female are same. This is the research problem. In different scenarios, this hypothesis may be different. Suppose in a business studies, average sales by product A, and you are comparing the average sale of product B, whether the average sale of the two products are statistically significant or insignificant. So your hypothesis will be like this: average sale of product A and average sale of product B. But your alternate hypothesis is basically a claim by the product manufacturer. Product
Sir,
manufacturer
your
is
notes
claiming
is not
that,
being shared.
okay,
Share new. We can't see that.
product manufacturer is claiming that their product B is an outclass product and it is more popular as compared to the product A. So your hypothesis will be like it. The researcher is interested in alternate hypothesis, right? Not in null hypothesis. Here as well, the claim is there. Males are claiming that females are getting the larger salary. So this is your hypothesis in which we are interested. So the procedure is quite simple. We calculate the p-value. Software will provide us that p-value. If p-value is less than or equal to 0.05, reject the null hypothesis. Reject H naught. So this is the procedure which we are going to introduce in the next segment, right? Is it mentioned? The board is showing to you. Now we are moving towards our screen in which we are implementing the code. Right now here. Here we have the two variables. One is the price and other is metallic. And what is the null hypothesis? Null hypothesis which we are going to check here, the average price of cars which have a metallic color is same as the average price of cars which we do not have a metallic color, non-metallic. This is your H naught. And your H1 is what? Your H1 is mu1 is not equal to mu naught. Acha, in R, by default, your alternate hypothesis will be not equal to, by default. So if I am not mentioning any of the alternate hypothesis, then it is assumed as it is not equal to. You can change it by some parameter by placing a comma here and placing the alternate value either less than or greater than. There are the further options over there in the command, but I want to keep the command simple as possible. So now run this command. Output is on the bottom of the screen. You can see the output of this command. What the output is indicating? Test. The value of test, t-test, 4.4 minus t. How this t-test is computed? Some student has the idea about the calculation of the t-test. X bar minus mu s upon n root. This is the simple t-test, but here we are applying either the pool t-test or a non-pool t-test. A very lengthy formulas are there for pool t-test and non-pool t-test. I'm not mentioning the formulas here. This statistics is computed by the software either by the pool t-test or by the non-pool t-test. किसी एक से ये calculate हुआ हो. Degrees of freedom is this. The p-value is this. We have just to focus upon the p-value. And your h0 is means are equal, and your h1, this is your h0, means are equal, and your alternate is means are not equal. Mean of metallic car is equal to the mean of non-metallic car. Mean of metallic is not equal to the mean of non-metallic car, right? P-value is what? P-value is 1e minus 5. So actually the P-value is 0.00001. This is your P-value. And the P-value is very small. Smaller than what? 5%, 0.05. Sometimes we compare it by 5%, sometimes we compare it by 1%, right? 1% is a strict criteria and 5% is a lenient criteria. At 5%, the null hypothesis is rejected. This hypothesis is not true. Alternate hypothesis is true. The prices are significant. Prices are significant means prices are significantly different. The prices of metallic car is significantly different with the prices of non-metallic car. This is the conclusion. But which cars have higher price, metallic or non-metallic? This is also mentioned here in the output. So the inferential output is this, in which we have the t statistics, the degrees of freedom, and the p-value. Focus is only on the p-value because p-value will give us a decision-making trick. P-value is smaller than 0.05, h0 is rejected. The second thing in the output is very important, which is this one. Group 0, 10, 162, group 1, 11. What these two numbers are? These two numbers are basically the prices x bar, sample mean of 0 means non-metallic car. These are the average price of non-metallic car. So I will mention it x bar 0 price, average price of non-metallic car in sample, and the average price of metallic car in sample. Metallic car and non-metallic car. So which is higher? So definitely sample is indicating that the price of the metallic car is higher as compared to the non-metallic car. So conclusion is what? Conclusion is this: mu metallic is larger than mu non-metallic. It is my conclusion in this analysis, right? So I'm concluding this here, and in this inferential procedure, I implemented comparison of two means by t-test, and command is very simple, t.test, and the price and the metallic car. These two variables I have chosen. Metallic car has two options, metallic and non-metallic, because it is a comparison of two means. So every factor variable which you are using here should have the two values. We cannot use fuel type variable here, because if I use the fuel type variable here, fuel type variable has three values: CNG, petrol, and one more thing was what I think, gasoline, whatever it is, right? So three values is there. So it is a comparison of two means, not three means. One more thing is I forgot to mention here is a 95% confidence interval. This is. So all of the inferential needs are covered here. So this is the difference of the two means. Metallic car minus non-metallic car has a difference of -1 to 18.9 up to -466.8. This is called confidence interval. So in the output, some of the output elements are related to hypothesis testing. This is hypothesis testing. This segment of output is inferential. It is called confidence interval, is a estimation procedure. This is testing procedure. This is estimation procedure. And what is it? It is called descriptive measure because just computing the mean of sample. So it is descriptive and these two are inferential. And in inferential, it is testing and it is estimation, confidence parameter estimation. So these are the simple concepts in hypothesis testing. Now, the another thing is ANOVA. ANOVA is what? ANOVA is a simple technique which we can apply for comparing more than two means. So just same command, same variable, not same command, price, average price of different types of fuel. Average price of CNG, average price of gasoline, average price of petrol, average price of diesel. The third category is not gasoline, is a diesel car. Command is AOV. AOV stands for analysis of variance. One student, Farhan Ali, is asking about changing the confidence interval level. Yes. Yes, Farhan, we can change the confidence level by putting some of the more options in that. I'm mentioning here the help of the t.test command. On the bottom of the screen, you can see help t.test. So what are the options? The help is not mentioned here, but the t.test will have more options in which we can change the level of significance and the level of confidence, right? Right now, it's not mentioning the help. I think if you people run this command, what output is there, I can't say anything about it. Now, moving next, and that is AOV. AOV stands for what? ANOVA, analysis of variance. ANOVA is a F test. Is not a T test, is a F test. F is statistics. Purpose of ANOVA is what? Comparing three or more means. So null hypothesis is what? Null hypothesis is written here. Average price mu. Mu is the population mean. Average price of CNG car is same as average price of diesel car is same as average price of petrol car. Whether the average price of these three types of car are same or not. This is your null hypothesis in ANOVA. And your alternate hypothesis is what? Your alternate hypothesis is at least two. At least two types of car have a significant or a different. So it will not mention here. Mu1 is not equal to mu2 is not equal to. This is not the alternate hypothesis of ANOVA. This is the wrong way of mentioning the alternate hypothesis. Alternate hypothesis is represented as at least two means are not same. I'm executing the command, the run command. You can see the output of ANOVA. This is the output of ANOVA. In the ANOVA output, no, I by error, I executed pair t-test command. ANOVA command is this. And summary statistics of ANOVA. This is your ANOVA table. And your ANOVA table has many columns. One of the column is degree of freedom. This is one column. Another column is sum of squares. Next column is mean sum of square. Last column is F statistics. Sorry, last column is p-value. P-value, this is. The p-value is 0.045. It is smaller than 0.05. Means the null hypothesis is rejected. And the means are significant. If the null hypothesis is rejected, we call it as the means are significant. And if the means are significant, we have to apply the another test named as pairwise t-test. The pairwise t-test is what it will indicate us which pair of values are significant and which are not. The pair dot t-test is output. I'm mentioning the output of pair dot t-test. Before moving next, run this command. This is the output. What this output is indicating? This output is indicating comparing diesel with CNG. This is the compare p values. All of these are the p values. 3 p values are there. P values. CNG and diesel. This is the p value of diesel and petrol. This is the p value of petrol and diesel. The petrol is compared with the CNG. Petrol is compared with diesel. Diesel is compared with CNG. So I have 3 null hypotheses against it. First H naught is mu CNG is equal to mu diesel. This is mu diesel. Another is H naught. This is why it is called pairwise t-test. All of the pairs are compared. Mean of petrol is same as mean of CNG. And the third null hypothesis is mean of petrol and the mean of diesel. These are the 3 null hypotheses. And the p-value is 0.04. 0.04 is less than 0.05. The null hypothesis is rejected. And the second one is 0.16, petrol and CNG. Petrol and CNG, this null hypothesis is accepted. And petrol and diesel, it has a 0.05. So less than or equal to 0.05, it is rejected. Equal to पे भी reject होगी or less than पे भी reject होगी. So out of the 3 null hypotheses, the 2 are rejected and the 1 is accepted. Means the prices of average price of petrol car and the average price of CNG cars are more or less same on average, but significantly different. The CNG car and the diesel car has a significant different prices, and petrol car and the diesel cars are also have a significant average prices. Now I am switching towards the last segment of this workshop, and that segment is called predictive analysis. Predictive. There are 3 major predictive techniques under the 2 categories. Instead of mentioning these categories here, I will switch toward the OneNote file and will draw it in a detailed way. This is my OneNote file and procedures. I want to mention the procedures. These are the procedures, but there is no space in this. I'm mentioning the procedures here. 2 major procedures are what? 2 major procedures are predictives. In the predictives, the 2 major procedures in predictives are referred to as supervised learning unsupervised learning. And under supervised learning, two methods are there. One is regression, which I will cover in this tutorial, LM, and another is classification. These two are supervised learning strategies. And in unsupervised learning, there is a procedure named as clustering. I will not cover the clustering here and the classification in this workshop, because due to the time constraint, we will limit the procedure to the regression model, which is done by linear model. Now moving towards the R studio, and regression models needs the scaled variables. So I will remove 3 columns in new data frame, and that data frame is I am naming that data frame as car df1. So in car df1, what we will do, we will store the all columns from the df1 except only the 3 columns. Column number 4, column number 6, column number 7. Column number 4 is the fuel type, column number 6 metallic color and automatic color. After removing these 3 columns, total columns remains 8, and all of the remaining 8 columns are numeric columns. So just run this command. A new data frame is created. You can check the structure of the new data frame, str car.df1, run that. Now you can see price, age, kilometer, 8 columns are there. And all of the 36 rows are there. Now, finding the correlations between the two variable price and age. The command is very simple, correlation of two variable, price and age, minus 0.86. Minus means what? If the age of car is high, then the price is very low, and vice versa. Means the prices of the old car are small and the prices of the relatively new cars are high. That is the meaning of strong, that is the meaning of negative correlation, but 0.87 means it's very high, because the maximum correlation is 1, and this is indicating as 0.8 minus means a very high correlation, very strong correlation. Maximum correlation in -1 and maximum correlation on the other side is +1. So -1 and +1, these are the two extreme values in correlation. If you want to find out the correlation matrix, so your command is this. Core, instead of mentioning the 2 columns, mention the name of the data frame. Which data frame? DF or DF1? So if I run the command by DF, there may be the errors. Why there may be the errors? Because in DF, there are some non-numeric columns. The correlation cannot be computed, the mean cannot be computed, the variance cannot be computed for non-numeric columns. So we need the data frame in which all of the columns are numeric. So DF1 has all numeric columns, but DF not. So मैं run करता हूँ DF. So you can see that X must be numeric. Means some of the columns in DF are not numeric. Now I am executing it again, DF1. So you can see the correlation matrix. The correlation matrix, again, I am running. Yeah, this is the correlation matrix. Muhammad Murad is asking, can't we compare by using the factor method? Yes, we can compare by the factor method. The procedure is different, and that procedure is called chi-square procedure. That is not correlation. That is a chi-square test of independence procedure, which can be used to compare the factor variables. And if you want to compare one factor variable with one numeric variable, then paired t-test or pool t-test, non-pool t-test can be used. Or if you want to compare more than 2, 3, then ANOVA will be used, right? So different types of variable, different type of research technique, different type of statistical procedure, right? Now coming to the another command by installing one library. Libraries are what? Libraries are basically external bundles in which more powers are introduced into R. So one of the package is HIMSC. This is the package. There are the two commands if you want to add the external packages. One command is install the package and then connect the package by library command. So I'm just executing these two commands. It will take some more time. In my computer, this package is already installed. Just I'm mentioning the library means in the next command which I am mentioning here is rcore. Instead of cor is a command which is a simple command in core R, finding correlations. But rcore, rcorr command, and here we have the two R's. In the previous command, I have only one R. What is the difference between the two? It can be executed by R. It cannot be executed by R directly because it is in the package HMISC, right? This can be done by R. This cannot be done by R directly because it is a command in this package. So install the package first and run the package first, then run this command. What is the difference between the output of these two commands? COR will represent only the correlations, but RCOR will represent the correlations along with their p-values. So I will mention you the output of the new command, this command. S.matrix data frame car.df1, car.df1, rcore. S.matrix is a conversion. Data frame is converted into matrix. What is this segment of command is doing? Data frame car df1, it is a data frame, which is a requirement of R. But HMISC package require not the data frame, it's a matrix to convert the data frame into matrix. And type is equal to Pearson correlation. And rcore is the command, and the result is stored in R. R is an object which will contains the two matrices. One matrix is the value of correlations, and another matrix contains the value of p-values. Check the output. Now, how can I see the values of R? Just place R and run it. Now you can see the two tables. This is the table of correlations. And bottom we have a table of. In the diagonal, I have one. Above diagonal, we have the correlations. Price and age. The correlation is 0.87. The correlation between price and kilometer is 0.6 minus में. HP with price. जितने हॉर्स पावर ज्यादा होंगे प्राइस ज्यादा होगी. Plus means HP is increasing, the price is increasing. CC is increasing, the price is increasing. Doors are increasing, the price is increasing. Tax is increasing, the price is increasing because the higher price car have a higher tax and the lower price car have a lower tax. The weight of the car is increasing. Only the one variable is there which reduce the price. And that variable is what? No, only two variables are there which reduce the price, and it's very obvious. The car becoming old, the price is decreasing. Negative correlation. The kilometers are higher, means your car is too old and it ran too far. Then the higher kilometers you have, the price will be reduced. So people will give you the less price to those cars which are these are the correlations. Now, second table is the table of p-values. This p-value is very small, this p-value, all the p-values are very small. Means all correlations in row number 1 are significant. Row number 1 correlations are what? The first hypothesis is correlation H naught. Correlation between price and age. This is P comma A. P stand for price and age is 0. And this is not correlation, this is p-value. P-value 0 means null hypothesis is rejected. Alternate hypothesis is what? Correlation is not 0. Correlation is not 0. So p-value 0 indicating that alternate hypothesis is true, null hypothesis is false. Second hypothesis will be what? Second hypothesis will be the price and the kilometer. The p-value is 0. So H naught will be H naught correlation between the price and kilometer is 0. And alternate hypothesis, it is not 0. And the p-value is 0, indicating that the null hypothesis is rejected, alternate accepted, means conclusion is kilometer and the price has significant correlation. So all of these correlations are significant. Only the few correlations are insignificant. And what that correlations are? This one. Only one correlation is insignificant. HP, it is the correlation in between the HP and CC. So if I am writing the hypothesis, correlation between HP and CC is 0. Alternate hypothesis is correlation between H and C is not 0. And 0.5 is indicating what? 0.5 is indicating that the null hypothesis is true, alternate is false. It is insignificant. So by the p-values, you can find out the inferential part of correlation. So this was the descriptive part of correlation, and this is the inferential part of correlation. Calculating the values of correlation is descriptive, and making the inferences about the hypothesis in correlation, it is called inferential. Now we are moving towards predictive. Looking at the scatter plot. The scatter plot is indicating that price is increases, then the kilometers are decreases, and vice versa. To make the model, regression model, we have to split the file into two segments. One segment is called training data, other segment is called testing data. The train index sample 1:1000. I am using 1000 rows only. If you are interested to use all the rows, so you can remove the 1:1000. And there is no need to place a C here because C is generally used for split columns. But here we do not know using split rows. We are using the continuous rows from 1 to 1000. How many rows I want to extract out of the 100, out of the 1000 rows? I want to extract the 600 rows. So it will generate the two sets. One set is of the set of 600 rows, and the other set contains the remaining 400 rows. So you have to run the three commands. 600 rows will be stored in the train set, and remaining 400 rows will be stored in a test set. So applying these three, we will have the structure of test and the structure of train. Anyone has a question regarding the segmentation? This is called the train and test split. If anyone has question in this segment, you can ask. 836 observations and 600 observations. 8 variables and 8 variables, right? The two segments are created, and one thing I think we have out of the 1000 rows, I have to remove this C because it is continuous in range, so there is no need to place a C. Now executing the commands again. And executing the structure again. Now, still it is showing that we have 836 observations and 600 observations, the remaining set. Means it is using all of the rows, 1400 rows. Now I am going to summarize the segment, making the linear model. Making the linear model is a regression model. We have to mention the dependent variable and predictor, dot indicating all predictors. And data is equal to train data. I am using the train data to build the model, and summary of the model will be shown in the output. This is the output. Very important output elements are estimates. These are the estimates. And the last are the p-values. These are the p-values. These two columns are very important column for all of you. Estimates will use to find out the model. The model will be written as y is equal to minus 1.31 into 10 raised to the power 4. 1.31 into 10 raised to the power 4. This is y-intercept. Plus minus 1.12 times age, minus 2.43 into 10 raised to the power minus 2 times kilometer, and so on. So you can write down the model by looking at these estimates. But the p-values are indicating what? Intercept is significant. Age is significant. Kilometer is significant. Stars means significant, and without stars means insignificant. So there are the two columns which are insignificant. One of them is CC, and other of them is quarterly tax. So regression output is indicating that the two columns are insignificant, CC and quarterly tax. All the remaining columns are significant. These are the significant columns because their p-values are very small. All of the p-values are very small, and in this case, you can see that the p-value is 0.4. In this case, the p-value is 0.39. So the p-values are very small. The betas are significant. If the p-value is large, then the beta is insignificant. The next thing is adjusted R-square, which is 0.84. And the last thing is the p-value, which is indicating whether the model is significant or not significant. So this is indicating that the model is significant. 0.84 is indicating that the 88.4% variation in price are due to all of these predictors. Means these predictors are 84.84% helpful to predict the price. Now I will modify the model by removing these two columns. The next step is quite simple. removing 2 columns and running the regression command again. Achha, now 2 columns I have to remove. One is the CC and other is the quarterly tax. What is the serial number of CC? Serial number of CC can be checked by call names. The call names command give you the all column names of train data set. Price, age, CC. CC 1, 2, 3, 4, 5. Column number 5. This is column number 5, which we have to remove. And quarterly tax 6, 7. Column number 7. You have to mention as column number 7 and the column number 5. You have to modify your code because in the file which I shared with you, I mentioned only column number 6. And the same 2 columns are reduced by the test sets. Running these 2 commands will reducing these 2 data sets, and structure of train and test will also be used. Structure of train and test. You can see the structure of train and test right now. The 2 columns are reduced. There is no CC column here, as well as there is no CC column at the bottom and top, and there is no text column in the both. Now executing the linear model command again by the remaining predictor. Now the remaining predictors are only 1, 2, 3, 4, 5. Only 5 predictors are remaining. One is price. Total columns are, I think there are 6 total columns are here. Now running the 2 commands again, and the name of the model is changed. You can see all of the predictors are significant right now. You can see all the predictors have, and model is 88.8%. And it is also a significant model. So we have to look these values in the output. You have to use estimates for writing model. You have to use the p-value for taking a decision whether the variable is significant or insignificant. In the early part of the lecture, I mentioned you dimension reduction. Dimension reduction. What is dimension reduction? Reducing columns. So this is the inferential procedure of dimension reduction. Another procedure is factor analysis, which we will not cover the factor analysis here in this workshop. Later on, in any other day, we can conduct another workshop regarding the factor analysis. Very few commands are remaining. Whenever we store the model in a data frame, car.lm2 is what? Car.lm2 is a structure in which the model is stored, right? So what are the elements of this car.lm2? I am just mentioning the car.lm2 with the $sign. If you place the $sign, it will indicate you how many other segments this output has. This output has coefficients. This output has residual. This output has effect, fitted values, terms, residuals, degree of freedom of residuals. So these are the elements. Any of the elements. Suppose you are interested only in coefficients. So run this command. Run this command car.lm2. This is the name of the model, and I am just mentioning coefficients. Run this. So not total output will be mentioned, only the coefficients will be mentioned. But there isn't any error. Car.lm2. I have not executed this, I think so. not mentioning the object. Understand what the error is. Dollar car.lm2. There is an error in car.lm2. Summary car.lm2. It's working. car.lm2 dollar coefficients. You can see only the coefficients here. Means the first column of the table. Acha, if you want to mention residuals, errors, the residuals can be 6 values of the residuals are here. What the predict command is, predict command will predict the dependent variable, predict the price. Price is my dependent variable. Predict the price for what? For training data set. The predict T, what predict T will do? Predict T will basically predict all of the values, means all of the prices or in training data set. If you want to show all of these predicted values, PREDT underscore T, these are the predicted values. As many number of observations we have in the training data set, we have the predicted values. If you want to see only the 6 predicted values, first 6, so you can mention the indexes. The last command to predict by test set. If you want to predict by test set, so the same model is used, predict command is used, and data set will be new data is equal to test. So now it is the command, and we want to show the predicted values for the testing data set. So these are the outputs of the predicted values, predicted prices of testing data set. This is the end of the file. If any one of you have question regarding the any segment of the workshop, you can discuss. Otherwise, you can leave a comment in a chat box whether you are satisfied with the elements of the workshop or you are interested to more details of the commands and the more segments of the workshops are needed in future. So you can leave the comments in your chat box. I'm just pausing